Hello student, and you're welcome to solve your physics past question class. Today we'll be focusing on the aspect of projectile in today's class. We'll be solving our question from the West African Examination Council as we solve our question across year 2000 to 2010. So the first question we have here says, a stone is projected horizontally from the top of a tower with a velocity of 10 meters per second. Full stop. If the height of the tower is 45 meters, find the time it takes for the stone to reach the ground, given the acceleration due to gravity to be 10 meters per second squared. So the first thing we have to note is that the time to reach the ground depends only on the vertical motion. So from our question, we're given a height of 45 meters. We're given acceleration due to gravity to be 10 meters per second squared. So you'll be using the formula for the vertical motion, which is h equals to half gt squared. Remember, h is the height of the tower, and g is the acceleration due to gravity, and t is the time for the stone to reach the maximum height. So substituting our values into this formula, so we have 45 equals to 1 over 2 times 10 and times t squared. So 2 divided by 10, that will be 5. So we have 45 is equals to 5t squared. So the next thing for us to do is to divide through by 5. So t squared is equals to 9. The next thing for us to do to get the final answer for our t is to square root both sides. So you have t is equals to square root of 9. So our time is therefore equals to 3 seconds as our final answer. The next question we have here says, a projectile is launched with an initial velocity of 20 meters per second at an angle of 30 degrees to the horizontal. Calculate the maximum height reached given acceleration due to gravity to be 10 meters per second squared. Now, you must understand that the vertical component of the initial velocity is Vy, that is vertical component, the vertical component. So that will be Vy is equals to V sine theta. So remember, so our velocity from our question is 20, and our degree theta, right, is therefore 30 degrees. So we have 20 sine 30, therefore that will be 20 times sine 30 will give you 0.5. So 20 times 0.5, and any number you multiply by 0.5, you'll be having half of the number. So that will be 10 meters per second. But that's not all. So the next thing for us to do is to find the formula for maximum height. So the formula for maximum height will therefore be h is equals to the initial velocity in a vertical component, all square, all divided by 2g. So we have h equals to v square y, then divided by 2g. So remember, what do we get for our initial velocity in a vertical component? That's 10 meters per second square. So we have 10 square, all divided by 2g, that will be 2 times 10. So that will be 100 divided by 20. So 100 divided by 20, that will be 5 meters. So this is the final answer of our maximum height of this question. So the next question we have here says, a projectile is launched at a speed of 50 meters per second at an angle of 45 degrees to the horizontal. Calculate the range of the projectile given acceleration due to gravity to be 10 meters per second squared. So we're told to calculate the range of the projectile. To calculate the range of the projectile, you must understand that the horizontal and vertical component of the initial velocity should be first solved. So let's solve the horizontal component of the initial velocity. So that will be Vx, which is equals to V cos theta, and Vy, which is vertical, will be V sin theta. So V cos theta will give us 50 cos 45. So 50 cos 45, cos 45 will give us root 2 divided by 2. So we have 50 times root 2 divided by 2 will give us 25 root 2 meters per second. Then for the vertical, we then have Vy is equals to V sin theta. So that will be 50 sine 45. That will be 50 times root 2 still divided by root 2. So that will be 25 also root 2 meters per second. Now, the next thing for us to do is to calculate the time of flight, t. So the time of flight, all right, will help us with the range, right? The time of flight, which is t capital T, is equals to 2 times the velocity of the initial velocity in the vertical component, all divided by g. So that will be 2 times 25 root 2, all divided by 10. So when you divide through, so you'll be having the time of flight to be 5 root 2 seconds. Now, that's not all. Then this will now help us to calculate for the range. So to get our range R, that will be Vx, that's the initial velocity in an horizontal component, times the time of flight. So range is equals to Vx times t. So that will be 25 root 2 times 5 root 2. So 25 root 2 times 5 root 2 will give us 25 times 5 then times 2. So that will give us 250 meter as our range. This is where we are going to stop for today's class on the concept of projectile. You'll be able to join us to solve more questions to better your understanding on projectile in physics. Thank you and bye for now.